Welcome to this explainer. Today, we're exploring a massive leap forward in software architecture. We're looking at CoveMan++, a platform that somehow merges mind-bending tech like quantum computing and artificial consciousness with the absolute bank vault security needed by modern enterprises. It's basically where bleeding edge meets completely unbreakable. So, how exactly do you deploy artificial consciousness and quantum computing with the security of a literal bank vault? It's the ultimate enterprise dilemma, right? Usually pushing for bleeding-edge innovation means introducing massive risk to your infrastructure. But what if a platform was mathematically guaranteed to be safe? Well, that is exactly the puzzle CoveMan++ was built to solve. All right, here's our roadmap for today. We've got 1, the real-time engine, 2, zero trust and ironclad uptime, 3, disaster recovery at scale, 4, quantum and consciousness modules, 5, enterprise strategy and markets, and finally, 6, the 4-phase deployment plan. Let's jump right in. Section 1, the real-time engine, speed meets collaboration. Before we get to the futuristic AI stuff, we have to look at how developers actually interact with this system day to day. You know, traditional setups are, well, painful. Fragmented IDEs and massive delays while you sit there waiting for code to compile. CoveMan++ completely flips this. They're using a Node.js WebSocket backend with operational transform. If you've ever watched multiple cursors flying around at once in a shared Google Doc, it's exactly like that, except, for writing highly complex enterprise code, complete with automatic real-time conflict resolution. And the result of that architecture? Sub 50 millisecond code completion speed. That is literally faster than the blink of an eye. By backing the editor with a high-performance Rust compiler, your enterprise devs can operate at the absolute speed of thought. You are never waiting on the system is always waiting on you. Section 2, zero trust and ironclad uptime. Because in a Fortune 500 environment, all that speed means absolutely nothing if the system isn't secure. Just look at these multi-stage deployment protocols. By using distroless minimal base images, they strip out everything except the app itself. It's kind of like removing all the doors and windows from a vault so hackers have 0 ways in. Containers are running as non-root users, specifically UID 65532. File systems are read-only, and all Linux capabilities are completely dropped. Top all of that off with 100% mutual TLS service mesh coverage, and you have an exceptionally hardened environment. And this zero-trust architecture is absolutely relentless. A user request doesn't just stroll through the front door. First, it hits the Kong API gateway, passes OpenID Connect identity verification, gets cryptographically validated by the service mesh, and undergoes granular role-based access control checks before it ever even touches the application. Identity and permissions are verified at literally every single layer. Because of this, let's call it paranoia-level security, CoveMan++ delivers a guaranteed 99.99% uptime. To put that into perspective, that's less than an hour of downtime for the entire year. It automatically scales to handle millions of requests per second without breaking a sweat. For enterprises, that kind of reliability is an absolute game changer. Section 3, disaster recovery at scale. So what happens when things go wrong outside the system's control? Like a massive cloud region outage? Well, check out how this active multi-region failover works. Minute 1, continuous archiving ensures data loss is practically 0, perfectly hitting the recovery point objective. Minute 2, let's say the primary region suffers a total collapse. Minute 3, the standby cluster, located in a totally different region, instantly scales up. Minute 4, automated failover kicks in. And by minute 5, full operational recovery is achieved, meeting the recovery time objective. It essentially heals itself in 5 minutes flat. Section 4, quantum and consciousness modules. With that ironclad fortress of security and recovery fully established, we can finally explore the really exciting stuff, the spaceship housed inside. But how do you run highly advanced volatile modules safely? The answer is proof-carrying binaries. CoveMan++ is the very first language where compiled executable files actually bring their own mathematical proof of correctness. The runtime engine strictly validates this proof before it ever executes, so it mathematically guarantees that experimental logic will run exactly as intended, without taking down the host system. Shielded by that zero-trust architecture, developers can tap into modules that, frankly, sound like science fiction. We're talking true quantum computing. They have variational quantum eigensolvers already running in production. There's an artificial consciousness engine, biological computing for simulating DNA, and, get this, even time travel debugging. It's securely pushing heterogeneous computing into entirely new, mind-bending realms. Section 5, enterprise strategy and markets. So, how does this platform inevitably capture massive market share across critical, highly regulated sectors? Well, the business case maps perfectly to Fortune 500 bottlenecks. In finance, high-frequency trading needs absolute correctness, so CoveMan provides proof-carrying trading algorithms. Aerospace needs provable safety, so they offer formal verification for flight control software. And for healthcare, it delivers lightning-fast, FDA-compliant FDHIR systems with embedded security that keeps sensitive patient data locked down tight. By completely transforming how software is built, literally eliminating up to 99% of traditional development costs, and shrinking time to market from years down to just mere weeks, CoveMan++ is on a $610 billion cumulative revenue trajectory over the next 5 years. Yeah, billion with a B. That revenue is driven entirely by enterprise licensing, compiler backends, and advanced cloud services. Section 6. 4-phase deployment plan. Now, how do massive legacy enterprises actually integrate this ecosystem without breaking their current workflows? They do it through a highly de-risked, year-long deployment roadmap. Months 1 to 3 lay the foundation, getting Kubernetes, Istio, and Kong in place. Months 4 to 6 bring the core services online, like the microservices, real-time WebSockets, and WASM runtime. Months 7 to 9 roll out the advanced zero trust and multi-region disaster recovery features. And finally, months 10 to 12 are all about optimization, performance tuning, and security operations. It's systematic, methodical, and totally seamless. Based entirely on the source documents, this multi-substrate architecture and entirely new paradigm of computing security yields a projected platform valuation of $2.64 trillion. Seeing the sheer scale of the engineering here, it really leaves us with one critical question. Can any enterprise actually afford the risk of not building on the most secure development platform in history? Thanks for joining me on this explainer. I really hope it helped you grasp the immense scope of CoveMan++.